Welcome back to the Dargslan Networking Mastery Curriculum. This is Stage 7, Lesson 52, and today we're stepping outside the building. We're going to explore WAN technologies and MPLS, leased lines, label switching, and Metro Ethernet, the systems that connect networks across cities, countries, and continents. Distance changes everything about networking, and over the next few slides, you'll see exactly why. So here's the roadmap for this lesson. We'll start by pinning down what actually separates a LAN from a WAN. It's more than just distance. Then we'll trace how WANs evolved, from dedicated leased lines into the flexible packet networks we rely on today. From there, we'll get into MPLS and how providers use label switching to move traffic efficiently. And finally, we'll look at modern enterprise options like Metro Ethernet and dark fiber. Let's start with that first distinction. A LAN lives inside your building or campus. You own the switches, bandwidth is cheap and abundant, latency is under a millisecond, and you treat the inside as semi-trusted. A WAN flips every one of those assumptions. The provider owns the gear, you pay monthly, latency jumps to tens or hundreds of milliseconds because of physical distance, and you have to assume the link is hostile and encrypt everything. Same word, network, but completely different engineering problems. Now, given those constraints, how did we actually build WANs over the last 60 years? It starts in the 1960s with leased lines, a dedicated copper pair from point A to point B, rock solid but painfully expensive. Then frame relay and ATM brought packet switching in the 90s. MPLS took over in the 2000s with label-switched paths and quality of service. Metro Ethernet simplified things by just handing you an Ethernet port. And finally, sd-wan flipped the model entirely. Cheap internet links plus software intelligence. Each step trades raw guarantees for flexibility and cost. Before we go deeper into MPLS, you need to know who's who inside a provider network. Sitting at your office is the CE, the customer edge. That's your router, your responsibility. It connects to the PE, the provider edge, which is the carrier's router that faces you and handles the heavy lifting of pushing and popping MPLS labels. And deep inside the cloud are the P routers, the core. They never look at your IP packets. They just switch labels as fast as possible. Remember this CE, PE, P trio, because every MPLS conversation from here on assumes it. So here's what actually makes MPLS special. In traditional IP routing, every single router along the path has to crack open the packet, look at the destination IP, and consult its routing table. That's a full lookup at every hop. MPLS flips that idea on its head. The ingress router decides the path once, pushes a small 20-bit label onto the packet, and from there, every core router just swaps labels. 17 becomes 42, 42 becomes 88, until the egress pops the label and delivers it. No IP lookups in the middle, just fast hardware switching. And because that label can carry QoS bits and steer traffic down specific paths, you also get traffic engineering and VPNs almost for free. Now let's actually look at that label. It's a 32-bit shim header, and we call it a shim because it slides right between the Ethernet header and the IP header, living in a layer of its own. Of those 32 bits, 20 carry the actual label value, giving you over 1 million possible labels. 3 bits handle traffic class for QoS. 1 bit, the bottom of stack flag, tells the router whether more labels follow, and the last 8 bits are a TTL that works just like IPs. And that stack bit matters because MPLS lets you stack labels, wrapping, say, a VPN label inside a transport label for hierarchical services. And that label stacking is exactly what makes MPLS so valuable to providers because they can sell real services on top of it. The most common is L3 MPLS VPN, where the provider actually participates in your routing, using VRFs to keep each customer's tables isolated. If you'd rather keep routing in-house, L2 VPN or VPLS gives you what looks like one giant switch spanning all your sites. Pseudowire is the simpler cousin, a point-to-point Ethernet circuit like a virtual cable between two buildings. And finally, traffic engineering lets providers pin specific paths through the network with guaranteed bandwidth and fast reroute, the foundation of those strict SLAs enterprises pay for. But here's where things get interesting for modern enterprises. Metro Ethernet has quietly become the go-to alternative. The carrier simply delivers your Ethernet frames between sites, so from your switch's point of view, the WAN looks like one very long cable. The MEF defines four flavors: E-line for a straight point-to-point link, ELAN to put every site in one virtual broadcast domain, E-tree for hub and spoke designs where leaves only talk to the root, and E-access for that last-mile handoff into a provider's POP. Simpler config, native Ethernet, and often cheaper than MPLS L3 VPN, which is why it keeps winning deals. So let's put all these options side by side. At the top, you've got the old guard, leased lines and MPLS, expensive but rock solid, perfect when an SLA is non-negotiable. In the middle, Metro Ethernet hits that sweet spot of price and performance, while plain internet broadband is cheap, cheerful, and unpredictable. Then there's sd-wan, which intelligently bonds multiple cheap links into something enterprise-grade, and dark fiber at the extreme. You're literally leasing the glass itself for data center interconnects or high-frequency trading. The real takeaway? Nobody picks just one anymore. Modern WANs are hybrid by design, MPLS for headquarters, broadband plus SD-WAN at the branches, dark fiber between data centers. Now, designing a hybrid WAN is one thing, surviving it in production is another. Let's talk about the traps that sink real projects. A single MPLS circuit feels safe until the fiber gets cut and your branch is dark for 2 days. Always have a second path, even a cheap LTE backup. Don't trust contracted QA without testing it yourself. And remember that 10 branches at 10 megabits will absolutely crush a 50 meg headquarters pipe. Read your SLA closely. 99% still means nearly 9 hours down a year. And never forget asymmetric routing, where traffic leaves one ISP and returns on another, and your stateful firewall quietly drops every packet. So let's pull it all together. The core mindset shift is this: a LAN is yours, fast, free, fully under your control, while a WAN is rented from a provider, slower, and billed monthly. The technology evolved from raw leased lines through frame relay, MPLS, Metro Ethernet, and now sd-wan, each generation cheaper and smarter. Remember the CEPEP topology, with the provider edge doing the label work. And remember that MPLS owes its speed to swapping 20-bit labels instead of looking up IPs at every hop. And in the real world, some modern WANs are hybrid, MPLS, broadband, and SD-WAN together, because you always need a backup path. And here's your cheat sheet. Keep this one handy. The essentials to remember: a WAN spans long distances. Leased lines like T1 and E1 give you dedicated bandwidth at fixed rates, and MPLS uses that 32-bit label stack to forward traffic along predetermined label-switched paths. The CE, PE, and P roles define who owns what in the provider's network, and on top of MPLS, you'll typically buy either L3 VPN, where the provider handles your routing, or L2 VPN, where they just hand you Ethernet and stay out of the way. And that wraps up our deep dive into MPLS and traditional WAN technologies. Next up in Lesson 53, we shift gears into the modern era. SD-WAN, where software intelligence layers on top of ordinary internet links to deliver what used to require expensive MPLS contracts. If this lesson helped things click, head over to dargslan.com or the YouTube channel, and I'll see you in the next one.